Welcome to the kickoff episode of the Secure by Design, powered by Secnora, where we dive into the real-world challenges and solutions shaping the future of cybersecurity. I'm Daniel Kulik, your host and moderator, and today we're exploring a topic that's rapidly moved from niche to mission critical: securing your software supply chain. The title says it all: your code, their target. So, attacks like SolarWinds, CodeCov, and Log4j have shown your pipeline is now part of the battlefield. And securing isn't just a technical issue, it's a strategic one. To help us make sense of this landscape and understand how to defend your CI/CD pipeline, we are joined by two expert guests. First, Joe Burnett, an independent cybersecurity specialist with hands-on experience, Kubernetes, hardening, and software supply chain security. And second, Rajiv, the CEO and co-founder of Secnora, a company that's actively implementing secure by design practices and bringing SLSA into real-world deployment. Together, we will unpack what SLSA really means, and how it applies in practice, and how to move from theory to implementation, even if you're not just getting started. Okay, let's kick things off with a quick look at the threats shaping the landscape and why securing the software supply chain should be at the top of your roadmap. Again, welcome everyone. Great to have you with us today. Before we dive into solutions and best practices, let's talk about why this matters so much right now. We have all seen the headlines: the SolarWinds, CodeCov, 3CX. These weren't just isolated breaches, they were major wake-up calls. Attackers aren't just targeting companies anymore, they are exploiting the hidden dependencies inside the tools we all rely on every day. So, Joe, can you walk us through what the software supply chain actually is and why it's become such a high priority attack vector?
Yeah, sure. Thanks for the question, Daniel. Software supply chain it's like any other supply chain. Whether to use an analogy of picking peppers from produce, gets packaged into a truck and moves to the grocery store to your house, right? You don't know, or you need to know what's going on during that process. And code is very much the same way, where software and applications are built on layers and layers of other projects, dependencies called libraries, that all along that process, from the bottom most basic utilities and programs, they're compiled and brought into the larger and larger applications. There's an opportunity for malicious actors or bad code to be injected or placed along that way. So this has become a how do you say, maybe a little bit more of a sneaky way to get exploits into systems, where instead of directly attacking through traditional means of a firewall or compromising somebody's credentials, you can sneak these exploits in far away in something completely unrelated, and next thing you know, that your mission critical systems are now vulnerable.
Okay. Thanks for breaking that down. This is interesting indeed. So this isn't just about securing your code anymore, as it looks like. It's about securing the entire ecosystem of things your code touches. All right. So I have another question also for you, Joe. So if you have looked at the real world incidents that we mentioned, like the SolarWinds and CodeCovs, looking at them, what patterns do you see repeating across these attacks?
Yeah, I think probably the most common thing is the lack of provenance, as in knowing what actual binaries and code is in your code, right? We in the industry use some stuff like an SBOM, a software bill of materials. Um, a lot of applications publish this stuff, but if you're not consuming it into your build process and into your pipelines when you're building your code, and not actually analyzing, do I have a vulnerable version of something or not? It's not being actually utilized, and you're making yourself vulnerable. So time and time again, it's really what people, or I should say, administrators, operators, companies not knowing what they're running.
Great. That's incredibly insightful. So we are not just talking about isolated incidents anymore. These are systemic weaknesses being actively exploited, it looks like. Okay. But Rajiv, now let's take it from the leadership lens. These risks aren't just technical problems, they are boardroom conversations now. So, Rajiv, from the company leadership point of view, what was your wake up call that made software supply chain security a strategic concern for Secnora?
Thanks, Daniel. Thanks for the question. So, when we talk about the wake up call, so when we got the wake up call, right? So, our turning point came when one of our Fortune 500 retail client asked, how can we sure when you deploy the code during the, let's say, Black Friday, and this code is not tampered with any kind of upstream. So at the same time, these exe utility backdoors that was surfacing all around the internet. So we realized that if we couldn't prove the provenance end to end, our customers' revenue also were at risk and was ours. So this kind of incidents pushed our supply chain strategy, or the need for the supply chain security strategy top line.
Perfectly and well explained. All right, now that we have framed the threat, let's talk about why this is suddenly a top priority. It's not just about preventing the next breach. It's about meeting new expectations from regulators, clients, and even your own engineers. So, Joe, again, let's get into what you are seeing on the ground. And my question to you would be, what are the biggest blind spots you see in typical DevOps or engineering teams when it comes to securing their pipelines?
Oh, thanks for the question, Daniel. Yeah, I'd say whether it's a small startup or a large enterprise, developers pick packages and libraries that complete their tasks, right? There's always a drive for features from product management, and not really slowing down and auditing what needs to be done, or picking up the tech debt and stuff, right? So when you find a project, it's often open source, that does what you need, that's good enough. I don't agree with this, right? Of course, but so if it works, ship it. It becomes the mentality, right? I can build my product, all the buttons in the website are working, and the code is working correctly, and the business is happy. You never have to look back at that, right? And this becomes an attack vector later on. We saw this with the XZ utils as a more famous example, where a maintainer, open source contributor, right, kind of worked his way as a sleeper for years into the project. And this is a foundational project, but people will come in, pretend to be a good person, and then sneak some bad code in there, and then now next thing you know, your stack is now running this exploited code. And that's a well-known project, right? But when you pick up some stuff that is from some random repo on GitHub, it's also hard to distinguish what is a good authentic source of good trustable code versus untrustable. Not throwing shade at anyone specifically here, right? But in my experience in Kubernetes, we'll do a lot of system monitoring, and there's some known authors that, like, this one is run this in production. Joe Elliott's, I think it's a node exporter or something, right? Some sort of logging agent, right? And well, it's just some guy's name from some GitHub on the internet. But like, this is the one the industry says to use. Like, this is, if you're not using that for doing this task, that's wrong. So a more junior developer can see, well, when I see, Bob Smith's, encryption algorithm and it works, well, that seems just as relevant, right? Like, why would I question that if we're already using these other, potentially weird looking names? So it's kind of a thing I see time and time again.
Right. Yeah, so it looks like those blind spots can be expensive, right? And I'm not just talking in dollars, but especially in downtime, trust, and like the compliance exposure and so forth. So I have another question just to follow up on this for you, Joe. How do SBOMs and frameworks like NIST, SSTF influence how teams need to think about the risk? What's your opinion on this?
Well, S bombs. It's a software bill of materials. That kind of comes back to what I was saying in the earlier segment, and even just now, of knowing what you're running. So when you have these intermediary projects that are, using something that could be questionable, having a concrete, trustworthy SBOM that you can then examine when you pull in this package, you can then use that to analyze your own security stance for the project you're building. I think teams should be looking holistically at their projects and not just at the package they're consuming, but through things like an SBOM, you can look through the whole stack and get the right scanners and things in place that will eliminate that risk or mitigate it.
Okay, got you. So am I right to assume that this isn't just the best practice anymore? It's becoming like expected, I would say. And in some industries, it's mandated. Okay, so I will move on to Rajiv and, just to find out from your leadership seat, Rajiv. So my question to you is, has client demand, regulation, or internal audits played a bigger role in pushing SecNora to invest in secure software supply chain practices, for example?
Thanks, Daniel. It's a very good question. So it depends. Some clients, they hands down, and some clients, they seriously consider these supply chain practices. And if you talk about the regulations, like it's like it depends geographically and how it is applied. And the rise of this supply chain security risk and the regulation also considering to adopt them. And nowadays, like so far, it was like regulations are set to the minimum bar, but now it's slowly getting to the better picture. But from what we see in the business world, so the enterprises when they do for the procurements or the RFPs, they now ask for the signed SBOMs, SLSA attestation, the must have. So there is a requirements coming, like if you're going to be like participate in certain RFPs, then if you cannot answer like okay yes, then you don't even go for the second round to get the pricing round. So that is the situation right now, and it's getting better. So the supply chain practices into the enterprise level is more and more increasing.
That's a great, point of view, Rajiv. I mean, it looks like a no-brainer, and security today isn't just about being secure enough, of course. It's about proving it to your customers and partners. This is the key nowadays. Okay, so we are definitely in agreement here. And next question for you, Rajiv, is how do you balance security improvements with, the product velocity in growing tech company like Signora?
So what we do is like, we give the customers with the secure velocity, right? So every security control sits as a part of the fully automated pipeline template, So this automated pipeline template, so that keeps the feature lead time under the 7 days on average, while still generating the signed provenance for every build they receive. So this is the one of the approach we have.
Okay, great. I mean, thanks both. I mean, two different point of views, but they're all coming to the same conclusion, and this is being heard very clearly. I mean, the bottom line, whether it's pressure for clients from different regulators or internal risk assessments, any inaction has a cost. That's the bottom line. It gets expensive. But the good news is forward-looking teams are finding smart ways to embed security into their development process without slowing down innovation pretty much. All right. All right, so far we have talked about the urgency and the risks, but let's shift gears now and unpack a framework that quickly becoming central to how modern teams secure their software, SLSA. All right, so let's start with the best practices and basics, and I'm turning to Joe, and my question to you, Joe, under this frame is, if you could, in very plain language, explain what SLSA is and how it is different from a checklist or certification, so to speak.
Yeah, let's start with it's pronounced salsa, but it's an acronym for the supply chain levels for software artifacts. It's a it's a maturity model for your build integrity, and it's not so much a certification of your code, but it's a way to describe verifiable guarantees that the build is reproducible, is isolated. There's signed guarantees along the way of the artifacts that are part of the process, so that when you produce the resulting build, this is leaves it up to the next user, the next consumer, in this chain, in this supply chain, to then make the analysis for themselves in a sane, structured, and easier to parse way.
Right. So this isn't a checkbox. It's more like a security maturity model that builds over time, so to speak.
Yeah.
Right? Okay, so clear on that. Okay, so next question, also to you, Joe.
Yeah.
Now, just want to know some, real cases, examples. Like, can you give, some real world examples on how, SLSA, for example, level 1 or level 2 actually changes, how the software is built or shipped out to the customer, for example.
Sure. Yeah. So, it's more than just the code you're running and building that goes into the supply chain. It's the process as well. So the various salsa levels try to define that. Um, let's going back to the produce truck example as an analogy. Um, we may be sure that you've got a carton of peppers or something coming from the farm to the grocery store, but the build process is like that truck that's moving it there. So if you can't trust the build, right, the truck to maybe tamper with it, you need to be able to know that the driver isn't messing with it, the freight company isn't doing some sort of tampering, even though it may end up looking like the produce and taste the same and looks the same. there's trust along the way, right? It's not just verifying the individual artifact, but verifying that the process is safe.
Right. Okay. I think you convinced me on this. Yeah, that makes it real, of course. So you are not just, trusting the final output, you're pretty much verifying how it was made, to be frank. Okay, now shifting to Rajiv. I'm curious from your side, Rajiv. Um, was adopting, the salsa a technical design a strategic one, or maybe both, you would say? What's tipped the scale at, at Secnora based on that?
I would say, Daniel, the both the technical vision and the strategic one. So, but the customer lens tip the scales. So basically, Salsa give us the universal language to prove to the, let's say, in the C level, let's say CTOs and the compliance team, that their software is very authentic and traceable, right? So strategically speaking, so this lowers their onboarding friction. So technically, it's leveled model to let us to iterate without stalling releases. So I would say that it's a technical vision and the strategy one for the both side.
Okay, got it. Okay. Yeah, I mean, and of course, I'm just thinking, I'm just trying to comprehend what you just said. And, I would say change is never plug and play. So to all of us, we need to think about it, more in that way. Great. So, to follow up on the previous question, I also wonder if there were any internal like champions or maybe resistance you had to manage in the whole process, Rajiv.
I
Can
would
you
say
think
like,
of some?
yeah,
Okay, so Rajiv, I was just wondering if there were any internal like champions or resistance you had to manage in the whole process, at Secnora. Could you think of any, examples of that?
Daniel, so always like the platform engineering team, so they lead the charge. So they are the champions, and the only concern, or maybe the resistance, I would say, like that when you build the signing, when you do the signing process, so the build is signing, slow down our builds and thus delay the customer releases. So that was the only concern. So then we moved on to do the pilot. So we ran a 2-day pilot that showed us level 2 signing adds about 12 seconds per build. So in this scale, so all the objection disappeared, I would say.
Okay, great. So, it is so clear now that, the salsa isn't just a framework. I would even attempt to say it's a mindset shift, and one that helps teams build trust into the software itself, not just audit it later. I would just conclude on that. All right. We have talked about the risk, the urgency, and the framework. Now let's get a little bit of practical here. So, Joe, I know you have worked with tools like Sigstore, Cosign. Which ones do you recommend to teams starting out with Salsa?
So, as my experience is primarily focused around Kubernetes and building Docker containers. Um, my recommendation is probably a little bit biased, right? But with Sigstore and Cosign, that's Cosign implements the Sigstore, and it's a great way to just start signing your containers, right? You sign them off the bat when you build them, publish that signature. You can publish the attestation to a transparency log. I think there's like the public record service that kind of comes into play, I think, out of the box. Similarly, like you could use tools like Sift or Gripe to analyze that resulting container, create an SBOM. You can then sign that artifact. Just getting these things producing these artifacts, these signatures and the SBOMs, like allow you to implement it later, right? Like you start sometimes some applications, some code just never gets updated, so if the last build was 6 months ago, right, and now you've got to rebuild it just to get a signature, well, you can get that process, get ahead of that process and get that in place, so that when you go to actually put some enforcement. And for me, I currently use a Kyverno admission controller. That's so when a pod goes to get loaded into Kubernetes, I'll check against the container registry to see if there's. It makes it pretty easy, but it's a simple definition. Check that the signature is authentic. If it's not, don't load this software. So if there was any tampering, we're not running that code in our production system. Yeah, it's a great way to get started. Now it could be authentic and full of bugs and vulnerabilities, but that's a whole different situation. But yeah, get that confidence that you know that your code is running as it should be.
Okay, got it. So, as you said, it's like a, great starter pack, and not everything all at once, but enough to build a foundation. All right. So now, also, Joe, tell me, please, what's one quick win and one common mistake, when trying to reach SLSA level 2 or 3, perhaps, if you could name
Sure.
maybe.
Yeah. Sure. Yeah, kind of got into it there with the Kyverno. The signing and an admission controller, you can reject an unsigned image. That'll give you an instant feedback loop. Another quick win. As part of the higher levels of SLSA is more about a hardened build system, right? So, for example, if you're using GitLab, GitHub, Jenkins, whatever, ensure that the secrets that are being passed to the build are only being passed to protected branches, for example. If you have some production secret that, a database password or something that's being built into your code, you don't want that anyone that can just like run a build, a developer, for example, can just get access to that and then, encode that in their system and into their build or access to the registry, right? They actually put the artifact registry. Like, there's a. What I should say is, locking down who can actually do the builds and publish the artifacts. In systems like in GitLab, it's just like restricted branches. It's a drop down. These branches can publish here, or these variables are available in these environments and such. It's
Okay.
really, I guess, using the tools that you have. And as far as some kind of failures,
Yep.
or common mistakes, right? It's that just because you're signing it doesn't mean your code's secure. All right, that's it's only part of the puzzle. There's still vulnerabilities that can sneak through or get in there. Or legitimately be included, just like bugs, right? Bugs are accidents that happen. They make it to production, but if you're not, taking those following steps, doing all these hardened builds and build environments, ephemeral runners and stuff on your pipeline, there's really not much value if you're not actually like checking with something like Sift or Gripe to see if the vulnerabilities are in there. So
Okay. These are really great insights, Joe. Really. Okay. Now, Rajiv, let's get into the operator's view. So, how did your team at Secnora begin implementation? So pretty much the question is, did you start with one pipeline, or maybe you went a little bit broader?
Yes, Daniel. So how we do is we always start with the single pipeline initially. So for one of our busiest SaaS customer, so we picked a single pipeline. So hardened the pipeline, and and then we ran it let's say in a test run or something, then everything ran smoothly. So no any kind of trouble. So once that tested run, then we move for the production. Then we try to run that, then see how it goes, and then when the real world test is passed, so then we roll out. We copy the same templates for the every other pipelines, then roll out, and we go for the broader implementation. So that's how our team is doing the implementation.
Okay. Seems very reasonable. So pretty much test, learn, and then scale, right?
Yeah, exactly.
Okay. So now I reverse the question a bit. What surprised you the most during the rollout, kind of phase? Something like harder or easier than you expected, or this was something that, it was something, like a process,
Yeah, I mean, so but we on the go, we learned the lesson, then we figured out the workarounds, and then we made those hurdles, pass. So that was harder than we thought when we started, and easier. The thing is with the SLSA, after every build carried a signed provenance, so lining it up with the this NIST STF checklist. It was basically copy and paste. So it's like a huge time server for the customers and the audit teams. So that is the thing that easier than we thought, I would say.
Okay, great. I mean, to me, the message is very clear. One, start small, choose the right tools, and expect some cultural lift at the end. Okay, so we have explored the mechanics of implementing salsa, but let's zoom out now. So, because for many companies, software supply chain security isn't just about what happens inside DevOps. Mainly, it's increasingly tied to how you meet industry standards, also earn trust. And so, Joe, let's connect the dots here. Tell me, how does Salsa fit into larger security ecosystems like NIST, OWASP, SAM, or ISO 27001?
Sure. Yeah. So, some things like NIST, SSDF, the Secure Software Development Framework, the SALSA levels will supply concrete controls to produce well-secured software and respond to vulnerabilities. As far as OWASP SAM, it's going to plug right into the implementation and verification streams as part of that. And in ISO 27001, SALSA evidence simplifies the audits by proving software integrity and supplier assurance.
Makes sense. So Salsa isn't an island, I would say. Pretty much strengthens your position across multiple frameworks. That makes perfect sense. Okay, good. Okay, but let's be honest, Joe. Is there a risk of compliance, feeder here, or can these frameworks be genuinely helpful? Really?
Well, some of the stuff. There's always a risk for compliance theater, right? There's there's always the individuals that know where the skeletons are buried, and and so forth. But some of the stuff like just getting that visibility, right? Producing signed SBOMs early and often are going to start to bring visibility into issues in your supply chain, and then actually implementing controls around that they're gonna actually start catching those problems, right? But in certain ways, like some gaps, like you can have a very hardened build process, everywhere. Your artifacts are from some source code to final container. It's secure or whatever. But you could, some organizations, if you leave a plain text admin password laying around, it all kind of isn't really you're not really protecting much, right? So there's always going to be risks, and some of them are bigger than others, but yeah, that's how it goes.
Okay. Yeah. No, I mean, pretty well said. I mean, the goal is real security, not just simulated assurance, I would say. So, Rajiv, let's talk some leadership again. Um, so, how do you communicate progress on secure development practices to your board or stakeholders at Secnora?
Yeah, sure, Daniel. So what we do at S.W.A.T is in the SLSA. So we do the provenance scorecard. So it can be like on demand. Some clients demand, let's say, frequently as they want, maybe let's say monthly, or maybe when they have a immediate demand. And otherwise, we have the practice. We send them monthly or quarterly provenance scorecard. SASA level per service or SBOM coverage, and any gaps, any gaps there, plus the remediation dates and so on. So it's simply very easily readable by the stakeholders, not very like a lot of technical pages of scorecard or something. It's a very easily readable one page visualizing a scorecard. The security teams and the non-technical team or the stakeholder can, they really quickly get into that and easily adapt it.
Okay, right, right. It actually makes a lot of sense here. Okay. Do you also see, software security as a differentiator for your brand at this point?
I would say not only for our brand, and as it is mainly for the, let's say, the software manufacturers. Absolutely, it's like since we adding the tamper evidence S-bombs to every artifact, so our win rate with heavily regulated prospect has jumped from 30%.
Great, great, great insight, Rajiv. Thank you. So it looks like we have, came full circle again from, covering risk and tools to frameworks and boardroom impact. And now, so like for everyone, if you take nothing else from today, modern software security isn't just about fixing bugs. This is what you need to actually comprehend. It is at the end of the day, it's about building trust, from the first line of code to the final, deployment, and at the end, aligning every layer of the organization around that particular goal. Okay, let's close out with some Q&As. We've had a fantastic conversation so far. Before we jump into specific questions, I still want to ask each of you something. We hear often from early stage tech leaders, and the question, of course, you can answer the same. I just want to know the answers and the perspective from each one of you. And the first, kind of like question is, maybe if you could give one piece of advice, it's in around like advice, your own personal experience. If you could give one piece of advice to a CTO or engineering lead, who's just starting to think about the whole thing, what would it be? And just, be precise and just, give one piece of advice. Maybe, Rajiv, please, the floor is yours.
Sure. Thanks, Daniel. So let's say if I want to, or maybe if you want to give advice to the CTO or the engineering leader team, right? So like about the SALSA, or maybe overall, right, about this stuff. So I would say like read your CI/CD like a production. So always treat it's like a production, and implement the least privileges and immutable bills and full audit trail. So all these things are key components, I would say. And additionally, if the pipeline is not hardened enough, well, so then it bring up it brings up the risk for the environment, right? So the every hardened workload downstream is living on the borrowed time.
Very valuable. Thank you. And Joe, the same question for you.
Yeah, sure. I kind of touched on this a little bit in the last segment, but I'd say get the inventory first, right? Create your SBOMs for your top, customer facing services, and you get that visibility alone will then start to bring in budget from other parts of the company to further harden and protect your systems. And that also then goes to show something that you can show your customers or the consumers of your service. Look, we have no vulnerabilities or something, right, in this product. So
Okay, fantastic. Before we go on and ask, pick up some questions from the audience, I promise it's gonna be last question directed to both of you, and it's more on a vision, I would say. And the question is, what do you think the next big frontier is in defending the software supply chain? Maybe I start with you, Joel, now.
Sure. I think this is thanks, I think it's a big frontier in general in the tech space, right? Is how AI is moving along and invading every aspect of technology, and AI models, machine learning models, they come with their own vulnerabilities, right? So securing machine learning, model pipelines, right? The model supply chain, if you will, is going to be the next thing. This is always a risk, right? When you go to use some new LLM, you don't know what the data set was even trained on, right? How do I know as an end user that there isn't going to be some bias in the output that's, say you're writing code, that's going to start linking in vulnerable libraries or, exploited code is going to be hidden in there when you're copying stuff wholesale because the training data comes from some closed source that's, unverifiable. That's where I think is where this is headed.
Yeah, I think I must agree with everything you said. All right, and Rajiv, your opinion?
As point out very well. So this now we have the AI ML, and then we are talking about like this AI ML in the supply chain, right? So in a scenario, maybe like the customer come and ask you, like, let's say, how do I know these model weights and training data set haven't been poisoned, right? So it's a one of the biggest question. So we are already extending the SLSA principles to cover the model artifacts, so the clients can deploy the AI features with the same confidence they have in the code. So we are already trying to accommodate and trying to like be on the track with the current tech trend.
Right. Okay. Great. I mean, it's so nice to see two different points of view from two different professionals that have been tackling this, subject for some, period of time. Okay. So I must say thank you so much, both of you, for great insights that you have provided to us today. And now. I will open up the floor for the questions from the audience, and we see if there is some there are some questions that we can quickly answer. So let's see what it is. Okay, and that brings us to the end of today's episode of Secure by Design. A really huge thank to our guests, Joe Burnett, for bringing the technical firepower, and Rajiv, the Secnora CEO and co-founder, for sharing real world insights from the leadership front lines. We really hope this episode helped you better understand how to defend your software supply chain and how to start putting SLSA into practice in your own CI/CD environments. I presume if you found today's conversation valuable, please make sure to subscribe to the podcast on your favorite platform. And if you're watching this on YouTube, hit that like button, subscribe, and don't forget to tap the notification bell so you'll never miss an episode again. Again, thank you so much for joining us. And remember, security isn't just a feature; it's a foundation. So stay secure, and see you next time on Secure by Design. Have a great day.
Thank you. Thank you.
Thank you.
Thank you.